Okay, so members, today we are going to see how we get the shortest distance from a point to a line. Of course, always the shortest distance is sometimes called the perpendicular distance the distance from a line to point. Now, I have two ways of getting this number. Now, the first approach is here. If you have this point, say from a point B, if you consider that you want the perpendicular distance from this point B to this line, where this line is given by this, and you have a point A on that line, all what you need to do is you get D, that distance, this distance D will always be equal to the vector of between the point on the line to that point times, you cross it with the power vector to that line, then over magnitude of that power vector. So, the example is here, a simple one. Find the perpendicular distance from a point this to a line this. Now, of course, we first arrange this line into the line we know properly. So now if you convert the vector form, is that my arrow will be now 1, 2, 3, then plus lambda 3, negative 1, 2. From here, so now I need a point on the line. This point is now here as A. So from here, my A is going to be 1, 2, 3. Of course, from the point was given as 4, negative 3, 10. And now I need also a power vector. So my power vector, U, from here you can determine our U. Our U from here is 3, negative 1, 2. Meaning that now, this perpendicular distance here, D, is going to be given by, or is that our D is going to be given by, you get AP, you cross it with the power vector over, you get the magnitude of that over the magnitude of U. So from there I just get AP. From here, if I get my AP, you know that AP is of B minus of A, which will be 4, negative 3, 10, then minus of A. The point on the line is the point on the line, which is here, 1, 2, 3. You see that from there, all I get is, here I get 3, then negative 5, then 7. And after that, you know that I need now to get magnitude of U. Okay, before that, let us cross AP and AU. So now my AP cross U will be, now my AP, which is 3, negative 5, 7. I'm crossing it with U, which is 3, 2. And if you cross, what do we get? We said if you cross two vectors, what you get is also a vector. So we say if we are crossing, you cover. If you cover this, then you get this. This will be negative 10 minus negative 7. So you see, this time this will be a negative 10 minus negative 7, which will give you a negative 3. Then you cover the second, you get a determinant between the remaining, in the remaining end. So you have 3 times this will be 6. Now minus, but you said whenever you are on on the day, you start with a negative. So this and this, which is 6, minus this and this, which is 21. And from there, you see you have negative 15. Now this is negative 15, and this will be now a positive 15. So there I have 15. You can cross it in your own way. Now when I cover this, I have this and this, negative 3. Then this and this, then minus into this and this, which is negative 15, and that will give you 12. So after doing that, members, now what I'm remaining with is to get the magnitude of those two things. So now, magnitude of AP cross U will be square root of When you square this, we get 9. When you square 15, what do you get when you square 15? You get 15 squared, shall be getting 2, 2, 5. When you square 12, is 144. And the answer we get there is root 378 units. Now, solve the magnitude of u. Magnitude of u will be square root of, use here, 9 plus 1 plus 4, which will be square root of 14. Now remember to just come and substitute in our formula here. So our formula from here, might will be, when you cross this, its modulus was root 398, 378 divided by root 14. And when you get 378 divided by 14, you get 27 and a root. So this will be root 27 units. So that's the first approach, members, root 27 units. The second approach, this one is, you get the general point. Now this general, you just know from our R, from here you get the general, just get this plus this, you get 1 plus 3 lambda, you get a general point. So you also get 2, now minus lambda, then 3 plus 2 lambda, you get a general point. Then from there, the idea used here is an idea of perpendicular vector. So see that if you want this, if you get the vector, this between, if you get this vector PR, it will be perpendicular to the parallel this line, because it's parallel this, it's going to be perpendicular to PR. So members, let us get this RP. So when you get RP, so our vector RP is going to be OP minus OR. From there, our OP, so that our OP is here for negative 3, then 10, then minus OR. OR now we take this one. This is the general. You just pick the one of this and you take it. R is the general, equals the general point now. So, 1. So that's what we get. This will be 4 minus 1, which will be 3 minus this 3 lambda. Then we have negative 3 minus 2, negative 5. This minus minus give you 9 positive. Then 10 minus 3, you get a 7. Then minus 2 lambda. So this is my RP, the vector RP. But when I look at RP, this RP is perpendicular to U, meaning that if they are perpendicular, their dot product is 0. So mean that now my RP dot U, I have to get a 0. Now I get my RP as then I dot it with U. My U is the parallel. Now our parallel is that our parallel was 3, negative 1, 2. This is equal to 0. Now we solve and we get the value of lambda. From here I see that this will be this and this. Equal to 0. So now when I add this, I'll be having this and this will give me negative 10. This will give me negative 15. Lambda equal to 2. Now this will be now 9 plus 15. That will be plus 5, that will be 14. Plus this, I get it as. So from there, you see that this is my 49 plus 5, then plus 14. You see that I'll be having 19, which will be 28. From here, my number becomes 28 over negative 15. So members, from there now, we get this value of lambda, a minute. Okay, so members, here we are we had normal. So this is negative 9 minus that's negative 10 minus this will be giving us negative 14 lambda equaling 2. Now this is 9 plus 5, that's 14, plus 14, that's 28. When I take the other side, it becomes negative 28. And from here, my lambda is 2. So if lambda is 2, we come and substitute here. So from here, my RP will be, now I'm substituting the value of lambda in RP, because RP, its magnitude is going to be the distance we want. RP is the distance, so we shall get RP, then we get its magnitude. So I'll be having now 3 minus, when I put here 2, I have that as 6. So I'll be having negative 5 now plus 2, then 7 minus 4. And what I get here is negative 3. This will be negative 3, and this is a positive 3. Now is that if we get the magnitude of RP, it will be our distance. Therefore, our distance will be magnitude of RP. So it's that our magnitude of now RP will be negative 3 squared plus negative 3 squared, then plus 3 squared, which will be the root of 27 units. So members, that's another approach. So we have 2 ways of getting the distance between, the distance from a line to a point. Don't forget to subscribe to the channel. I sign out.